maximum velocity with which a car can go round an inclined. A car can go round an inclined curved road, and that inclined curved road should be a smooth road. This is an inclined curved road, and O is the center, and R is the radius of the curved road, and AB is the inclined road. AB is the inclined road, and theta is the angle of banking. And this is a vehicle or a car on the curved road, on the inclined curved road. This is a car, and we can denote the weight of the car. mg is the weight of the car which is acting vertically downwards. Now we can resolve the weight mg of the car into two rectangular components, and this angle is theta, and that is angle of inclination, and this rectangular component is mg cos theta, such that this component mg cos theta is perpendicular to the inclined curved road. We can denote the normal reaction on the car applied by the inclined road. R is the normal reaction on the car. Now we can resolve R, and this R or normal reaction acts at an angle theta with the vertical. We can resolve the normal reaction R into two rectangular components. Vertical component of normal reaction is R cos theta. Horizontal component of normal reaction R is R sin theta. R sin theta is acting radially inwards, and this is the car, and in this case R sin theta is acting parallel to the horizontal direction, and we can denote the centripetal force Fc, and that centripetal force Fc is supplied by the rectangular component of normal reaction, that is R sin theta. This is the imaginary line along which the car is taking a turn with the tangential velocity v. With the tangential velocity v. Let v be the tangential velocity. V be the tangential velocity of a car which is taking a turn. Around the inclined smooth road, around an inclined curved road, and that inclined curved road should be smooth of a radius r. V be the tangential velocity of the car. Now the weight mg of the car acts vertically downwards. Weight mg of the car acts vertically downwards, and the reaction R on the car applied by the road, will be perpendicular to the inclined road, and this reaction acts upwards in a direction perpendicular to the inclined road AB. R is at an angle 90 degree with the inclined road AB. In this case, the reaction on the car, that is R, can be resolved. The reaction on the car can be resolved into two rectangular components, R cos theta and R sin theta. R cos theta acting vertically upwards, and R sin theta. In this case, normal reaction R can be resolved into two rectangular components, R cos theta and R sin theta, acting radially inwards. R sin theta is acting radially inwards towards the center O of the inclined circular path. In equilibrium, R cos theta is equal to mg. Also, R sin theta supplies the necessary centripetal force Fc, which is acting radially inwards. Also, the rectangular component R sin theta of normal reaction on the car, provides the necessary centripetal force, Fc for taking a turn. Therefore, r sin theta is equal fc. R sin theta is equal to fc. Therefore, r sin theta divided by r cos theta is equal to fc divided by mg, or comma tan theta is equal to fc divided by mg, or comma tan theta is equal to 1 by mg into mv square by r. Since centripetal force Fc is equal to mv square by r, which is the centripetal force, therefore tan theta is equal to v square divided by rg. Tan theta is equal to v square divided by rg, where theta is the angle of inclination, or theta is the angle of banking of the curved inclined road. Therefore v square is equal to tan theta rg. Therefore v is equal to root over tan theta rg. V is equal to root over tan theta rg, and that should be maximum velocity or maximum value of velocity. V max is equal to root over tan theta rg, where this velocity v can be denoted by V max, which is the maximum velocity, with which the car will be trying to take a turn around the inclined curved road. Vmax is equal to tan theta rg, which is the maximum velocity with which the car can take a turn. Maximum velocity with which the car can take a turn around the inclined curved road, and this inclined curved road should be smooth. That means no frictional force Fk acts on between the wheels of the car and the road. Here tan theta is equal to v square divided by rg, where theta is the angle of inclination of the inclined road. Therefore theta is equal to tan inverse v square by rg. Theta is equal to tan inverse v square divided by rg, where r is the radius of the circular orbit. Theta is equal to tan inverse v square by rg, which is the angle at which the outer edge under bracket A of the curved road, of the curved road is raised above the inner edge under bracket B of the curved road. Theta is equal to tan inverse v square divided by rg, which is the angle of banking. That means angle at which the outer edge of the curved road is raised above the inner edge to provide the necessary centripetal force, for the revolution of the car round the inclined smooth curved road, to provide the necessary centripetal force to the car for taking a turn round the inclined curved road. Theta is also called the angle of banking. The process of raising the outer edge of a curved road, under bracket smooth, outer edge of a smooth curved road above the inner edge, for providing the necessary centripetal force, to the car to take a turn, is called banking, of the curved road, of the smooth curved road. Now tan theta is equal to v square divided by rg. Again from the triangle ACB, tan theta is equal to h by b, that is AC by BC, where h is the height of the inclined plane. H is the height of the outer edge. H is the height of the outer edge under bracket A of the curved road with respect to the inner edge B. H is the height of the outer edge under bracket A of the road above the inner edge B, and B is the breadth. B is the breadth of the inclined curved road. So finally we get V square divided by Rg as equal H by B, where H is the height of the inclined curved road, and finally we get V as equal root over H by B into Rg. V, that will be the maximum velocity with which the car can take a turn round the smooth inclined curve road, and that will have the expression V equal root over H by B Rg.